Okay, students. So today we are starting with October November 2025 paper 4 variant 2 A level physics का paper. So let's start with this paper. डंग 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 अच्छा जी ये आ गया हमारा first सवाल. So let's see this. The earth may be considered the earth may be considered as a uniform sphere of radius this. अच्छा जी ये आपका अर्थ का रेडियस है दैट इज 6.37 10 is the power of 6. Cambridge is at a point on the Earth's surface that has an altitude of 52.2 degrees north to the equator as shown in figure 1.1. अच्छा जी कैम्ब्रिज जो है एक 52.2 डिग्री के एंगल पे ओके. As the Earth spins on its axis, the Cambridge move in a circle that is parallel to the equator but with a smaller radius. देखो हो क्या रहा है. You have to understand this motion. Cambridge is moving in a circle parallel to the equator like this. कैम्ब्रिज किस तरह मूव कर रहा है इन अ सर्कल parallel to the equator. If I can make it somehow like this, Cambridge is moving like this bhai. Cambridge is moving like this parallel to the equator. What a beautiful representation I have drawn. Very good. Okay, so as you can see here, Cambridge is moving in a circle parallel to the equator like this. This is the path of Cambridge, somewhat along these lines. Perfect. Okay. Now let's see क्या लिखा हुआ है बेटा. Okay. Show that the radius of the circle around which Cambridge moves is 3.910 raised to the power of 6. We have to somehow calculate the radius of this pink wala circle. How will we calculate this value of r? Very, very easy. Humbly, just humbly realize that this is a right angle ट्रायंगल है ना. ये एक राइट एंगल ट्रायंगल है. कैन यू ऑल्सो रियलाइज दैट द रेडियस ऑफ द स्फीयर दैट इज दिस लाइन 6.37 10 से पावर 6 मीटर है बेटा. ये वाली लाइन दैट इज द रेडियस ऑफ द स्फीयर इज व्हाट 6.37 10 से पावर ऑफ 6 मीटर. ओके, दिस इज अ 90 डिग्री और राइट एंगल ट्रायंगल. नाउ if you further realize what is this angle. Can you tell me what will this angle x be? Yeah, let's do it one thing. Let's label it as theta. Can you tell me what will this angle theta be? This complete angle is 90 degree. 90 degrees equals to theta plus 52.2 degrees. 90 minus 52.2, that is theta. Theta comes out to be what? Can you guys calculate that? 90 minus 52.2. This comes out to be 37.8 degrees. So the angle theta is coming out to be what? The angle theta is coming out to be 37.8 degrees. ये angle theta क्या आ रहा है 37.8 degrees. This is your hypotenuse. 6.3710 raised to the power of 6 is your hypotenuse. You have to calculate this r. R क्या है भाई? Perpendicular. You will say sine of theta is equals to perpendicular over hypotenuse. What is your theta? 37.8 degrees. You have to calculate the perpendicular distance, that is r. What is your hypotenuse? What is your hypotenuse? 6.37. 10 raised to the power of 6 meters multiplied. 6.37 multiplied by 10 raised to the power of 6. Sine of 37.8 is your value of r. Can you calculate the value of r? 6.37 10 raised to the power of 6 into sine of 37.8. What does your value of r comes out to be? Value of r क्या आ गई बेटा? Value of r comes out to be 3.9. 10 raised to the power of 6 meters is your value of r. This is method number 1 of doing things. Beta, this is method number 1 of doing things. Let me make all of this a little small and put it here. दिस इज द फर्स्ट मेथड ऑफ डूइंग थिंग्स. इसको हम यहाँ पे रख देते हैं somehow. Can I make it a little small? Yeah, I can do that. I want to show you guys one more method. The method that I have done in black is method number one. भाई ये क्या है? Method number one. Now, there is another method to do this as well. I am doing method number two in green. Although this is a one marker question, I don't need to show you guys two methods, but it can come in handy sometimes. The method two भी देख लो. Instead of considering this green wala right angle triangle, let's consider this blue wala right angle triangle. Instead of considering the green wala right angle triangle, let's consider this blue right angle triangle. Again, the hypotenuse is 6.37 10 is the power of 6. This is your 90-degree angle. This is your R, which you have to calculate. ये कैसे calculate करते? This now has become your base. You will say cosine 52.2 is equals to base over hypotenuse. What is your hypotenuse? 6.37 10 is the power of 6. Cosine 52.2 is equals to base divided by 6.37 10 is the power of 6. 6.37 10 is the power of 6. Cosine 52.2 is equals to your base. Can you calculate this answer? 6.37 10 is the power of 6 into cosine 52.2. What does your value of r comes out to be? Again, आपकी r की value क्या आ गई? 3.910 is the power of 6 meters. Simple as that. Nothing complicated here. Easy. Let's further move ahead. Calculate the speed. Okay, let's keep this method too. यहाँ पे let me make this smaller. डुडुंग डुडुंग. I am keeping it in their places ताकि जब मैं export करूँ ना तो मुझे थोड़ी सी आसानी हो जाए. ओहो बड़ा ही ये हमने ज़्यादा लिख दिया है. अच्छा इसको यहाँ पे ले आओ. ठीक है. Calculate the speed at which Cambridge moves around the circle. You have to calculate v, speed of Cambridge. V is equals to rw. What is your radius? And g. 3.9 10 raised to the power of 6. How will you calculate w? W is equals to 2 pi over capital T. Now, can you realize Earth एक कंप्लीट रोटेशन परफॉर्म करता है इन 24 आवर्स. द टाइम पीरियड ऑफ अर्थ इज 24 आवर्स. तो यहाँ पे हमने टी की जगह 24 आवर्स लिख देना. 3.9 10 is to the power of 6 multiplied by 2 pi divided by the time period, that is 24 hours. But you have to convert the hours into seconds. 1 hour has 60 minutes. 1 minute में 60 seconds. Can you humbly calculate the answer? Anyone in the chat who would love to calculate the answer of velocity? Velocity का answer comes out to be 280 meters per second. Let's further move ahead, beta. A student of mass 58.6 kg stands on horizontal ground in Cambridge. Okay. Determine the magnitude of the resultant force. Okay, what will be the resultant force that acts to cause the circular motion? बेटा हमेशा याद रखो the resultant force that cause circular motion is known as what? It is known as centripetal force. Centripetal force का क्या फॉर्मूला होता है बेटा? Centripetal force का क्या फॉर्मूला होता है? Centripetal force is equals to mv square over r. What is the mass of the person? 58.6 kg. What is the velocity of the person? हाँ जी ऊपर आओ जरा. 280. 280 का square. What is the radius? हाँ जी 3.910 is the power of 6. 3.910 is the power of 6. Can you calculate the centripetal force? हाँ जी centripetal force निकाल सकते हो बेटा. Can you calculate the centripetal force? Centripetal force comes out to be 1.2 Newton. Simple. On figure 1.2, draw an arrow to show the direction of the resultant force that acts on the student. Now, please, for the love of God, focus carefully. You have to mark the direction of resultant force या आपने direction of centripetal force mark करनी है. How will you do that? Do you realize this student और केमरेज, ये बेटा स्टूडेंट या फिर केमरेज एक सर्कल में मूव कर रहे हैं पैरेलल टू द इक्वेटर. हाउ विल द रिजल्टेंट फोर्स एक्ट? The resultant force will be towards the center of the circle. F. Erase this blue वाला circle. अच्छा जी. On figure 1.1, draw labeled arrows from the student to show the direction of the forces that act on the student to cause this resultant force. बेटा student पे कौन कौन सी forces act करेंगी to cause this resultant force? First of all, you have this downward. Oh, एक तो ये one note. First of all, you have this downward force of weight. Then you have this normal reaction force, or you can say contact force. Oh, can I make it in a beautiful manner? This is your contact force. I hope I am able to show you guys a tangent to the circle का path. ठीक है, this is your contact force. The resultant of these two will give you your centripetal force acting towards the left. Simple. Let's further move ahead. State Newton's law of gravitation. बेटा Newton's law of gravitation क्या कहता है? What does Newton's law of gravitation state? The gravitational force between two point masses, two point masses is directly proportional to the product of masses and inversely proportional to the square of separation between them, to the square of separation between them. Simple. Let's further move ahead. One of the basic assumptions of the kinetic theory of gas is that there are no forces exerted between the molecules of the gas except during collision. बेटा assumptions of kinetic theory of gases ये कहती है कि there are no forces between the gas molecules. State two other basic assumptions. दो और basic assumptions क्या हैं? You will say the gas molecules are moving in continuous random motion. And second assumption क्या होगी बेटा? Gas molecules are moving in continuous random motion. Second assumption क्या होगी? The collision between the gas molecules are perfectly elastic. Collisions between gas molecules are perfectly elastic. Simple. Nothing complicated here. Easy. आगे बढ़ते हैं. Hydrogen gas consists of molecules that each have a mass of this. भाई हाइड्रोजन गैस के एक मॉलिक्यूल का मास ये है. हाइड्रोजन may be considered to be an ideal gas. ठीक है, हाइड्रोजन एक आइडियल गैस है. A spherical balloon. Okay, let's highlight this as well. A spherical balloon contains 0.016 moles of hydrogen gas at a temperature of 282 Kelvin. At this temperature, the volume of the gas in the balloon is this. So basically, you have the volume of the gas, number of moles N, temperature T, What else do we have? We have the mass of one molecule as well. Okay, determine the pressure of the gas. How will you do that? PV is equals to nRT. You have to calculate pressure. Pressure is equals to nRT divided by the volume. Number of moles है beta? Yes, 0.016. What is your value of R? R की value ऊपर data booklet से निकाल लो. I'm just doing it so that you guys know where is the R की value. 8.31 molar gas constant. Let's substitute it here. 8.31 multiplied by the temperature, that is 282, divided by your वॉल्यूम की वैल्यू. वॉल्यूम की वैल्यू क्या है? 1.87 10 is the power of -4. What does your pressure comes out to be? 0.016 8.31 into 282 divided by what? 1.87 10 raised to the power of -4. Put these values in the calculator and you will realize the answer of pressure comes out to be what? 2.01 10 raised to the power of 5 Pascal. Simple. Now estimate the average separation of the hydrogen molecules in the gas. बेटा हमने average separation निकालनी है between the hydrogen molecules in the gas. How will we do that? Sit back, relax, have a chill pill. Can you realize you have 0.016 moles of hydrogen gas? 1 mole of hydrogen gas contains 6.02 10 raised to the power of 23 molecules. 0.016 moles of hydrogen gas कितने molecules contain करेगा? If 1 mole has 6.02 10 raised to the power of 23 molecules, 0.016 moles के पास कितने molecules होंगे? X का आंसर क्या आ गया? 0.016 into 6.02 10 raised to the power of 23. What is the number of molecules in 0.016 moles? Let's calculate it. This comes out to be what? 9.632 10 raised to the power of 21 molecules. बेटा इतने molecules present हैं in 0.016 moles. Okay, so now what should we do? Now if you realize आपको पूरी गैस का वॉल्यूम भी गिवन था. You were given the volume of the entire gas as well. 1.87 10 raised to the power of -4. Okay. If 9.632 10 raised to the power of 21 molecules का volume is what? 1.87 10 raised to the power of -4. एक molecule का volume क्या होगा? If the volume of 9.632 into 10 raised to the power of 21 molecules is 1.87 10 raised to the power of -4 मीटर क्यूब, तो एक मॉलिक्यूल का वॉल्यूम कितना होगा? सिंपल रेशियो मेथड. x comes out to be what? 1.87 10 raised to the power of -4 divided by what? 9.632 10 raised to the power of 21. Can you calculate the volume of one molecule? हाँ जी, वॉल्यूम ऑफ वन मॉलिक्यूल निकाल सकते हो, बिल्कुल निकाल सकते हैं भाई. This comes out to be what? The volume of one molecule comes out to be what? 1.94 10 raised to the power of -26 meter cube is your volume of one molecule. But sir, we didn't have to calculate the molecule, we had to calculate the separation, this lovely little thing separation. Now write down a key point. Write down a key point. Write down a small little key point somewhere here or there. You can say the separation between, एक काम करते हैं इसको यहाँ पे लिखवा देते हैं थोड़ा सा ना. You can write it here. ठीक है, द सेपरेशन बिटवीन gas molecules is the cube root of volume of gas molecule. बेटा गैस मॉलिक्यूल के बीच में जो सेपरेशन होगी दैट विल बी अ क्यूब रूट ऑफ द वॉल्यूम ऑफ द गैस मॉलिक्यूल. गैस मॉलिक्यूल का वॉल्यूम क्या है बेटा? 1.94 10 is the power of minus 26. Can you calculate the separation? Yes. सेपरेशन किस तरह आएगी बच्चा? टेक अ क्यूब रूट. क्यूब रूट ले लो, सेपरेशन निकालो. 1.94 10 is the power of minus 26. What does your separation comes out to be? 1.94 10 is the power of minus 26. बताओ सेपरेशन किसके इक्वल आ गई? सेपरेशन कम्स आउट टू बी 2.69 10 is the power of minus 9 meters. This is how you calculate the separation. Always remember separation किसके इक्वल होती है? Cube root of the volume के. Successfully you have calculated the separation. Let's move ahead. अच्छा, अब क्या लिखा हुआ है? Use your answer in C part 2 to calculate the average gravitation force between adjacent molecules in hydrogen gas. Okay. Suppose this is your first molecule of hydrogen gas. This is your second molecule of hydrogen gas. Perfect. The distance or the separation between them is what? अभी निकालिए 2.69 into 10 raised to the power of what? 10 raised to the power of minus 9. अच्छा जी, सेपरेशन क्या आ गई है? 2.69 10 raised to the power of minus 9 meters. दो हाइड्रोजन गैस के मॉलिक्यूल्स हैं. You have to calculate the gravitational force. What will you say? Gravitation force is equal to capital G capital M small m divided by R square. What is the value of gravitational constant? 6.67 10 raised to the power of minus 11. What is the mass of one hydrogen molecule? Did we calculated it? Yeah, we are given. Luckily, I'm given it. The mass of one molecule is given 3.34 10 raised to the power of minus 27. Okay. 3.34 10 raised to the power of minus 27 is the mass of this hydrogen molecule. इस hydrogen molecule का भी mass same ही होगा. 3.34 10 raised to the power of minus 27 divided by R square. What is the separation? 2.69 10 raised to the power of minus 9 का whole square. Can you calculate the gravitational force? Yes or no? 6.67 10 raised to the power of minus 11. 3.34 10 raised to the power of minus 27. 3.34 10 raised to the power of minus 27 divided by what? 2.69 10 raised to the power of minus 9 whole square. This comes out to be what? The gravitational force comes out to be 1.03 10 raised to the power of minus 46 Newton. Let's make it a little smaller. आपकी ग्रेविटेशन फोर्स क्या आ गई? 1.03 10 raised to the power of minus 46 Newton. Okay. अब देखो क्या लिखा हुआ है. By considering the weight of a molecule, okay, suggest with a reason whether your answer in D part 1 is consistent with the assumption of kinetic theory of gases that there are no forces between molecules. First of all, the weight of molecule निकाल लो. Do you have the mass of one molecule? Yes, 3.34 10 raised to the power of minus 27. Can you calculate the weight? Yes, the weight of one molecule will be equal to mg. M is 3.34 10 is the power of minus 27. Gravitation field strength क्या है? 9.81. Can you calculate the weight of one molecule? Yes, sir. 10 raised to the power of minus 27, 9.81. The weight of one molecule comes out to be what? 3.28. 10 raised to the power of minus 26 Newton. Can you realize this is the weight of one gas molecule? बेटा weight की 10 की पावर क्या है? 10 रेज़ टू द पावर ऑफ -26। एंड द ग्रेविटेशनल फोर्स की 10 की पावर क्या है? 10 raised to the power of -46. The force of attraction or the gravitational force has a power of 10 raised to the power of -46. The weight has a power of 10 raised to the power of -26. Hence, the gravitational force is negligible, or the forces between the molecules are negligible compared to the weight. You can write here, you can say the gravitational force. The gravitational force has what? The gravitational force is, yeah, has a magnitude of 1.03 raised to the power of -46 Newton, which is negligible compared to weight. Compared to weight. और वेट का क्या आंसर आ रहा था? 3.28 10 raised to the power of -26 Newton. Hence, no forces between molecules. Simple. Easy peasy, lemon squeezy. Let's further move ahead. आगे बढ़ते हैं बेटा. State what is meant by two objects being in thermal equilibrium. What is meant by two objects being in thermal equilibrium? अगर दो objects thermal equilibrium में इसका मतलब क्या है? This means that both the objects are at the same temperature and there is no net transfer of thermal energy. यहाँ पे आप लिख सकते हो, this means both the objects are at same temperature and there is no net transfer of heat energy. भाई heat energy का कोई transfer नहीं हो रहा, and this means both the objects are at the same temperature. Figure 3.1 shows a type of thermometer called a constant volume gas thermometer. अच्छा जी, ये constant volume gas thermometer है. Okay, let's see what happens in this. Let's read about this. थोड़ा सा इसको read करना पड़ेगा. The thermometer is used to determine the thermodynamic temperature of the gas in the glass bulb. Okay, so let's highlight this. This thermometer is used to determine the thermodynamic temperature of gas in the glass bulb. यहाँ पे जो भी गैस होगी उसका thermodynamic temperature आपको मिल जाएगा. ओके. The glass is immersed in the environment for which the temperature is to be measured. अच्छा जी, जिस भी environment का आपने temperature measure करना है उस environment में आपने glass bulb को immerse कर दिया. The height of the movable glass tube. अच्छा, movable glass tube का है ये रही. This is your movable glass tube. Okay. Is then adjusted so the level of liquid on the left hand side aligns with the reference level X marked on the fixed glass tube. अच्छा जी, ये एक फिक्स ग्लास ट्यूब है, रेफरेंस लेवल मार्क्ड X यहाँ पे अलाइन कर रहा है. ओके. The line Y is marked on the side of the movable glass tube. The level of liquid Y is higher than at X as a result of pressure of gas in the glass bulb. बेटा ये वाली गैस के प्रेशर की वजह से क्या हो रहा है? द लेवल ऑफ लिक्विड इन दिस मूवेबल ग्लास ट्यूब इज हायर कंपेयर टू दिस फिक्स ग्लास ट्यूब. ओके. The difference in height between the liquid levels at X and Y is then measured using the scale. Okay. बेटा डिफरेंस इन हाइट आपने यहाँ पे मेजर कर ली. ओके, बिटवीन एक्स एंड वाई. ओके. The thermodynamic temperature T of the gas is directly proportional to the pressure of the gas. Thermodynamic temperature is directly proportional to the pressure of the gas and the pressure is directly proportional to delta H. So ये लिख लो. Thermodynamic temperature is directly proportional to pressure. Pressure is directly proportional to change in height. Perfect. लेट्स फर्दर सी क्या लिखा हुआ है. The value of change in height can be used to calculate the pressure of the gas. Yeah, that's true. Pressure का क्या formula है? Rho G change in height. Whenever you have to calculate the pressure in gases, this is the formula that you will use. In order to do this, the gravitational field strength is used. Yeah, gravitational field strength is used. Change in height is used. Along with the property of the liquid. State the property of the liquid that is used to calculate pressure. बेटा कौन सी प्रॉपर्टी ऑफ लिक्विड हम यूज करेंगे टू कैलकुलेट प्रेशर यूजिंग दिस फॉर्मूला. द डेंसिटी ऑफ द लिक्विड लिख लो. डेंसिटी ऑफ द लिक्विड. सिंपल. आगे बढ़ते हैं बेटा. Before the measurement of delta H can be made, the glass bulb needs to reach thermal equilibrium with the environment for which the temperature is to be measured. अच्छा जी. हाइट मेजर करने से पहले हमने क्या करना है? वी वांट द ग्लास बल्ब. इस चीज को थर्मल इक्विलिब्रियम में आना होगा विद द सराउंडिंग. ओके. स्टेट टू डिसएडवांटेजेस ऑफ यूजिंग अ कांस्टेंट वॉल्यूम गैस थर्मोमीटर टू मेजर टेम्परेचर. फर्स्ट ऑफ ऑल, राइट ऑफ द बैट आई कैन सी कि ये बड़ा स्लो थर्मोमीटर है. इट हैज़ अ वेरी स्लो रिस्पॉन्सिव रेट या वेरी स्लो. हाँ, रिस्पॉन्स रेट कह सकते हो, लार्ज रिस्पॉन्स टाइम कह सकते हो. it takes a large time to measure the temperature. यहाँ पे you can say the thermometer, yeah, you can say it has a large response time, hence it cannot measure, it cannot measure rapidly changing temperature. बेटा इसका response time large है, hence it cannot measure rapidly changing temperatures. Hence, it cannot measure rapidly changing temperatures. Simple. What is the second disadvantage of this type of thermometer? Second disadvantage क्या है इस type of thermometer का? Very easy. It is hard to carry. बहुत bulky है. It is bulky. It is difficult to set up. It is bulky and difficult to set up. Difficult to set up. Perfect. Suggest one situation in which a constant volume gas thermometer would be an appropriate type of thermometer to choose for measuring temperature. बेटा measuring temperature के लिए कब ये suitable होगा? When will it be suitable to measure temperatures? हाँ जी. When the temperature is constant throughout. या when the temperature is constant for a larger amount of time. When the temperature of environment is constant for a larger या longer amount of time. लिख दो. larger तो अच्छा नहीं लगेगा, longer amount of time लिख दो. amount of time. Simple. Let's further move ahead. Liquid level X aligns with 2.31 centimeter on the scale. At 0 degree centigrade, level Y aligns with 8.69 सेंटीमीटर. ठीक है भाई. जब आप 0 डिग्रीज पे हो, एट 0 डिग्री सेंटीग्रेड, परफेक्ट, योर लिक्विड लेवल X is 2.31 centimeter, your liquid level Y is 8.69 centimeter. Can you calculate the change in height at 0 degree centigrade? 8.69 minus 2.31. चेंज इन हाइट क्या हो जाएगा? 8.69 माइनस 2.31, 6.38 centimeter is your change in height. Okay, this is at 0 degree centigrade. At temperature theta, अच्छा जी, थीटा के बारे में अभी हमें नहीं पता. At temperature theta, Liquid level Y aligns with 7.83. अच्छा जी, you need to remember कि level X remains fixed. बेटा level X क्या करता है? Fix रहता है, okay? At temperature theta, what happens? Your X is again fixed, that is 2.31 centimeter. Y is 7.83 centimeter. Can you calculate the change in height? 7.83 minus 2.31. बताओ change in height क्या आ गई बेटा? 7.83, 2.31. Change in height comes out to be 5.52 centimeter. At a temperature of theta degree centigrade, change in height क्या आ रही है? 5.52 centimeter. You have to calculate a value for theta in degree centigrade. Sit back, relax. This question will get solved very easily if you remember one key point. Temperature is directly proportional to change in height. और बेटा ये कौन सा टेम्परेचर है? दिस इज द थर्मोडायनेमिक टेम्परेचर. The temperature measured in Kelvin is directly proportional to change in height. If two variables are directly proportional, we can apply a ratio method. Sir, what will we do? 0 डिग्री सेंटीग्रेड इन टर्म्स ऑफ कैल्विन क्या हो जाएगा? 273.15 कैल्विन. अब सर आपको कैसे पता ये? आई रिमेंबर दिस कन्वर्जन. Kelvin is equals to degree centigrade plus 273.15. If your degree centigrade is 0, what will happen? Kelvin will be 273.15. तो ये तो बेसिक कन्वर्जन मैंने किए यहाँ पे, ठीक है. फॉर दोज हु आर रियली रियली बैड एट फिजिक्स, मैंने ये बेसिक कन्वर्जन भी करके दिखा दिए, ठीक है. सो इफ योर टेम्परेचर इज 273.15 Kelvin, द चेंज इन हाइट क्या है? 6.8 6.38. अगर आपका टेम्परेचर ये है, चेंज इन हाइट ये होगी. फॉर अ चेंज इन हाइट ऑफ 5.52 सेंटीमीटर, what will be the temperature? Okay, टेम्परेचर निकाल सकते हो for a change in height of 5.52. Yes, x comes out to be 273.15. 5.52 divided by 6.38. Can you calculate this? 273.15, 5.52 divided by what? 6.38. The temperature in Kelvin comes out to be what? 263.3. बेटा टेम्परेचर ये आपका आया है in terms of Kelvin, but you have to calculate the temperature in degree centigrade. What will you do? 263.3 is your temperature in Kelvin. इसको डिग्री सेंटीग्रेड में कैसे कन्वर्ट करेंगे? अगेन द सेम इक्वेशन. कैल्विन का टेम्परेचर इज इक्वल टू डिग्री सेंटीग्रेड प्लस 273.15. कैल्विन में क्या टेम्परेचर है? 236.3 degree centigrade. 273.15. Take this to the left side. 236.3 minus 273.15 is equals to your temperature in degree centigrade. Can you calculate the answer? This answer comes out to be negative 36.8 degree centigrade is your temperature. Theta. Negative 36.8 degree centigrade is your temperature. Theta. Simple, easy peasy, nothing complicated here. आगे बढ़ते हैं बेटा. लेट्स मूव अहेड. अच्छा क्या लिखा हुआ है? A cylinder contains a fixed mass of an ideal gas at a pressure of 2y and a volume of 6x. अच्छा जी, आपका प्रेशर क्या है? 2y, वॉल्यूम क्या है? 6x हो गया. ओके. The gas undergoes a sequence of changes from its initial state A through the states B, C, and D, and then finally back to its initial state A, as shown in figure 4.1. अच्छा जी, आप A से B जा रहे हो, B से C जा रहे हो, C से D, D से A. Okay. Figure 4.2 shows the variation with time t of the internal energy of the gas. Okay. ठीक है, internal energy of the gas इस तरह वेरी कर रही है. State the first law of thermodynamics. How easy can A2 get? बेटा आपने फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स बताना है. व्हाट विल यू से? चेंज इन इंटरनल एनर्जी दैट इज डेल्टा यू. क्या आपको बात याद है? चेंज इन इंटरनल एनर्जी इज इक्वल्स टू हीट सप्लाइड टू द सिस्टम प्लस वर्क डन ऑन द सिस्टम. बात याद है? यू विल से change in internal energy and you can also give the symbols. यहाँ पे साथ साथ ब्रैकेट में ना सिंबल भी दे दो. चेंज इन इंटरनल एनर्जी ऑफ द सिस्टम डेल्टा यू. चेंज इन इंटरनल एनर्जी ऑफ द सिस्टम डेल्टा यू इज इक्वल टू व्हाट? हीट सप्लाइड टू द सिस्टम क्यू प्लस वर्क डन ऑन द गैस या ऑन द सिस्टम. ऑन द सिस्टम. सिंपल. चलो आगे बढ़ते हैं. लेट्स मूव अहेड. Figure 4.1 and 4.2. Use figure 4.1, 4.2 to determine the general expression for the internal energy U of the gas when it has a pressure of P, volume of V. अच्छा जी, internal energy का general expression निकालना है. Now this was a very weird question. बड़ा ही weird question था. Let's see how we will do this. चलो focus करते हैं. If you realize at point A, now I will utilize this white space for the working. At point A, can you realize the pressure is 2y, volume is 6x. Pressure multiplied by volume क्या हो जाएगा? 2 into 6 that is 12x y. Similarly, at point A आपकी internal energy क्या है बेटा? What is the internal energy at point A? Can you realize? You are going from 0 to 20. आप 0 से 20 जा रहे हो. 20 यूनिट्स कवर कर रहे हो. In how many boxes? 10 boxes. One box is equals to how many unit? 2 units. तो ये क्या हो जाएगा? 18xy. So when your pressure PV is 12xy, internal energy is equals to what? 18xy. Let's analyze option B as well. Yeah, position B as well. At position B, can you realize pressure is 2y, volume is 2x, P into V is what? 4xy. And at position B, your internal energy is what? This thing. ये किसके equal है? 6xy. Internal energy is equal to 6xy. Perfect. अब पोजीशन सी की भी वर्किंग कर लो बेटा. Let's do the working for position C. At position C, if you realize volume is 2x, pressure is 5y, P into V किसके इक्वल हो जाएगा? C पे P into V किसके इक्वल हो जाएगा? 10xy. Internal energy will be equal to what at C? Internal energy at C is equals to, let me zoom in a bit. Internal energy at C is equals to this region, that is 15xy. Okay. Internal energy at C is 15xy. Can you guys notice a pattern? I am doing every single position. कोई भी position हम leave out नहीं कर रहे ताकि आपको pattern समझ आ जाए. At point D, pressure is 5y, volume is 6x, PV क्या हो जाएगा? 30xy. And at point D, what is your internal energy? Somewhere here, this will be 45. At point D, your internal energy is 45 xy. Can you humbly realize one thing? क्या आप चीज एक रियलाइज कर सकते हो? whatever your value of PV is, बेटा जो भी आपकी value of PV है, if you multiply it by 1.5, you will get the value of internal energy. Whatever your value of PV is, if you multiply it by 1.5, you get the value of internal energy. Whatever your value of PV is, if you multiply it by 1.5, you get the value of internal energy. Whatever your value of PV is, if you multiply it by 1.5, you get your internal energy. What does your relationship become? Internal energy is equals to 3 over 2 or 1.5 multiplied by PV. You can keep this thing here. That's why I told you guys this was a weird question. Internal energy is equals to 3 over 2 PV. Perfect. And इसका और कोई करने का हल भी नहीं है because you have to give the answer using figure 4.1 and 4.2. So this is the only possible solution here. Okay. Now next parts get easy. Let's see. Let's see आगे क्या लिखा हुआ है. Okay. Uh, an ideal gas at thermodynamic temperature T contains n number of molecules. Okay. Use your answer in B part 1 and the equation of a state for an ideal gas to reduce the expression for U in terms of n and T. Identify any other symbols that you use. बेटा इंटरनल एनर्जी का फॉर्मूला क्या निकाल लिया 3/2 PV. We also know that PV is equals to NKT. Can you replace this PV with NKT? Yes. Internal energy is equals to 3/2 NKT. Simple as that. Nothing complicated here. Determine an expression in terms of x and y for the work done on the gas during change A and B. बेटा A और B के दौरान जो वर्क डन ऑन द गैस हो रहा है we have to calculate that. Now for those students who have been studying regularly from me, we study that there is no formula for work done on the gas. You can never ever calculate work done on the gas directly. बेटा work done on the gas कभी भी directly नहीं calculate कर सकते. तो सर फिर हम क्या करते हैं? Now, what do we do? हाँ जी, what do we do? क्या करें? फिर हम एक टेक्निक करते हैं. Work done by the gas is equal to pressure into final volume minus initial volume. Once you have calculated work done by the gas, negative of work done by the gas is equal to work done on the gas. These are the only two formulas that you have to remember. There is no formula to calculate work done on the gas directly. So let's first of all calculate work done by the gas from A to B. A to B के लिए work done by the gas निकालते हैं first of all. Come here. Can you realize the pressure? So let's do it work done by the gas. The pressure is 2y. What is the final volume? Final volume क्या है 2x. Initial volume क्या है 6x. What does your work done by the gas comes out to be 2y into negative 4x. This comes out to be negative 8xy. This is your work done by the gas. ये क्या हो गया work done by the gas. However, अगर आपका work done by the gas negative 8xy आ रहा है, you need work done on the gas. Work done on the gas is equals to negative work done by the gas. What is work done by the gas? Negative xy. Work done on the gas हो गया 8xy. You place it here. Now you have to calculate the work done on the gas during CD. बेटा CD प्रोसेस के दौरान आपने वर्क डन ऑन द गैस निकालना है. सिट बैक रिलैक्स. Now what should I do? How should I create some space? Let's make this a little small. Let's take this to the top side. अच्छा, अब आपने निकालना है वर्क डन ऑन द गैस फ्रॉम सी टू डी. अब हमें पता है सर वर्क डन ऑन द गैस का कोई डायरेक्ट फॉर्मूला नहीं होता. हाउ कैन यू कैलकुलेट वर्क डन बाय द गैस फ्रॉम सी टू डी? Pressure into the final volume, that is point D, minus the volume at the initial position, that is C. What is the pressure? 5y. What is the final volume? 6x. What is the initial volume? 2x. 5y into 4x. This comes out to your 20xy. Your work done by the gas comes out to be 20xy. Okay. अब आपने वर्क डन बाय द गैस थोड़ी ना निकालना है बेटा. The work done by the gas from C to D comes out to be 20xy. But you have to calculate work done on the gas. Work done on the gas is equal to negative of work done by the gas. Negative 20xy. Work done on the gas comes out to be 20xy. From C to D, your work done on the gas is 20xy. Negative. From A to B, your work done on the gas is 8xy. Positive. Nothing complicated here. अब next part को देखो. Use your answer in part C and the first law of thermodynamics to determine an expression in terms of x and y for the net thermal energy Q supplied to the gas during one full cycle A, B, C, D, A. अच्छा, first law of thermodynamics क्या होता था? First law of thermodynamics is change in internal energy Q plus work done on the gas. Can you realize your cycle का starting point? बेटा आपका cycle भी A से start कर रहा है, end भी A पे कर रहा है. When the starting and the ending point of the cycle are same, change in internal energy is zero. You can write it here. When the starting and ending point of the thermodynamic cycle are same, when the starting and ending point of the thermodynamic cycle are same, the change in internal energy becomes zero. You can write this key point, store in your registers, this will come in handy. ठीक है भाई, change in internal energy क्या हो गई? This change in internal energy becomes zero. You want to calculate the value of Q. Do you have work done on the gas? Yes, sir. There are two types of work done on the gas, 8xy and negative 20xy. 8xy, negative 20xy. 8xy minus negative 20xy, what does this answer comes out to be? Negative 12xy. Bring this to the other side. Q is equals to 12xy is your thermal energy supplied. Simple as that, nothing complicated here. आगे बढ़ते हैं बेटा. Let's further move ahead. अच्छा, अब क्या लिखा हुआ है भाई? A steel ball on the end of a thin string oscillates with a small oscillation as shown in figure 5.1. अच्छा जी, एक बॉल है जो कि oscillate कर रही है with a small oscillations as shown in figure 5.1. ठीक हो गया. The displacement of the center of the ball from its equilibrium position is x. अच्छा जी, displacement की वैल्यू क्या है? x, या displacement को हमने वेरिएबल दे दिया x. Figure 5.2 shows the variation with displacement of the acceleration of the ball. Acceleration versus displacement का graph given है. Okay. Explain how figure 5.2 shows that the oscillation of the ball are simple harmonic. हमने बताना है how does this figure shows कि that the oscillation of the ball is simple harmonic. कैसे बताएंगे? First of all, can you realize the graph is passing through the origin? Can you realize the graph of acceleration versus displacement is passing through origin? इसका मतलब क्या है? इसका मतलब ये acceleration will be directly proportional to displacement. Write it down. The graph is passing through origin, indicating that acceleration and displacement are directly proportional. Indicating that acceleration and displacement are directly proportional. बेटा ग्राफ ओरिजिन से पास कर रहा है. दिस इंडिकेट्स एक्सेलरेशन एंड डिस्प्लेसमेंट आर डायरेक्टली proportional. What else can you write? You can say that the negative gradient, देखो इस ग्राफ का gradient negative है, it is a downward sloping line. This is a downward sloping line. This graph has a negative gradient. You can say the negative gradient of the graph shows that acceleration and displacement act in opposite direction. You can say the negative, the negative gradient of the graph shows that the acceleration and displacement acts in opposite direction. That the acceleration and displacement acts in opposite directions. Simple. Let's further move ahead. Okay, so now you have to determine the time period t of the oscillations. कैसे करेंगे बेटा? First of all, to determine the time period t of the oscillations, you have to realize that the gradient of acceleration versus displacement graph किसके equal होता है? Negative w square के. Can you calculate the gradient here somehow? Yeah, this is 1.0 comma 0. Which other point can we take? We can take this point. This is x-axis में 1. What is this in the y-axis? Negative 11. Okay. So negative 11. So we have 2 points, 0 comma 0 and 1 comma negative 11. Okay. What are we about to do here? y2 minus y1 minus 11 minus 0. x2 minus x1. Okay. Is equals to the gradient. Gradient comes out to be negative 11. Gradient is equals to negative 11. Now focus carefully on the board. Gradient किसके equal हो गया भाई? Negative 11. So bring this down here. You can say gradient is equals to negative 11. The gradient of the graph is equals to negative w square is equals to negative 11. Cancel, cancel. W is equals to under root 11. W का फॉर्मूला क्या होता है? 2 pi over capital T is equals to under root 11. Can you calculate the formula of T? 2 pi divided by under root 11. What does your time period comes out to be? 2 pi divided by under root 11. Time period comes out to be 1.89 seconds. Simple as that. Nothing complicated here. आगे बढ़ते हैं. At time t is equals to 0, the displacement of the ball has its maximum value. अच्छा, time t is equals to 0 पे आपकी value क्या है? Maximum है, okay. The ball is immersed in a trough containing thick oil so that the ball is just below the surface of the oil. This results in the subsequent motion of the ball being heavily damped. State what is meant by damping. Damping का मतलब क्या होता है? Loss of energy of oscillations due to resistive forces. You will say damping का मतलब क्या होता है? Loss of energy of oscillations due to resistive forces. रेजिस्टिव फोर्सेस की वजह से लॉस ऑफ एनर्जी को हम कहते हैं डैम्पिंग. इजी पीजी, नथिंग कॉम्प्लिकेटेड. आगे बढ़ते हैं. ऑन फिगर 5.3 sketch possible variation of displacement of the ball between time t is equals to 0 till time t is equals to capital 2t. अच्छा जी, आपने टाइम t इज इक्वल्स टू 0 से लेकर टाइम t इज इक्वल्स टू कैपिटल 2t तक डिस्प्लेसमेंट वर्सेस टाइम ग्राफ बनाना है. गिवन दैट द बॉल इज हैवी damped. whenever heavy damping occurs, हमेशा याद रखो, whenever heavy damping occurs, what happens? हाँ जी, whenever heavy damping occurs, do you remember what happens? ये heavily damped system याद है, कुछ notes में पढ़ाया था. Whenever heavy damping occurs, amplitude या displacement, you can say, displacement reduces to zero gradually within a quarter of a cycle. बेटा जब भी आपकी heavy damping होती क्या होता है, आपका एम्पलीट्यूड या डिस्प्लेसमेंट जीरो पे डिक्रीज कर जाता है ग्रेजुअली. करंटली आपका एम्पलीट्यूड क्या है? लेट्स सी व्हाट इज द एम्पलीट्यूड. अच्छा जी, ये चीज़ है आपका एम्पलीट्यूड. एम्पलीट्यूड इज व्हाट? 1.2. परफेक्ट. सो द एम्पलीट्यूड is 1.2, that is somewhere here. It reduces gradually to zero. One second. Like this. It reduces gradually to zero. This is the curve that you need to draw here. Simple. Now you have to define electric field at a point. What will you say? Force per unit positive charge is your electric field की definition. आगे बढ़ते हैं. An isolated conducting sphere in a vacuum has a capacitance of this. This is your capacitance. Charge of this. Okay. On figure 6.1, draw lines to represent the electric field outside the sphere due to the charge on the sphere. You have a positively charged sphere. Always remember the electric field lines emit out of a positive charge. बेटा अगर आपका चार्ज पॉजिटिव है, इलेक्ट्रिक फील्ड लाइंस बाहर की तरफ ओरिजिनेट करेंगी. लाइक दिस. You have to calculate the electric potential at the surface of the sphere. How will you do that? Capacitance is equals to charge over voltage. You have to calculate this small little voltage. Voltage is equals to charge over capacitance. कैसे निकालेंगे बेटा? चार्ज क्या है? चार्ज इज 83 पिको कूलम. अच्छा, 83 into 10 raised to the power of minus 12. What is your capacitance? 69 picofarad. Wow, everything is in pico. Why so small? This comes out to be, what does your electric potential answer comes out to be? 1.2 volts is your electric potential. Now you have to determine the radius of the sphere. How will you do that? Electric potential is equals to what? Yes, charge divided by 4 pi E naught R. You have to somehow calculate this value of R. Take this to the left side. R is equals to Q divided by 4 pi E naught V. What is the value of charge? 83 10 raised to the power of minus 12. 4 pi. What is the value of E naught? 8.85 10 raised to the power of minus 12. You can see it from the data booklet as well. बेटा E naught की value तो आप data booklet से भी निकाल सकते हो. If I scroll to the top, 1 second. Here we have it. 8.85 10 raised to the power of minus 12 is your E naught. Perfect. Yep. Let's move down. What is your electric potential? Electric potential की क्या value है बेटा? If you scroll up, 1.2. Can you calculate the radius of this charge? इस charge का radius निकाल सकते हो? Yes, the radius of the charge comes out to be 0.62 meters. Simple. Let's further move ahead. Calculate the electric field strength. इलेक्ट्रिक फील्ड स्ट्रेंथ का क्या फॉर्मूला होता है? E इज इक्वल्स टू Q डिवाइडेड बाय 4 पाई E नॉट R स्क्वायर. व्हाट वाज योर चार्ज? चार्ज अगर ऊपर चले जाओ, 83 10 इज द पावर ऑफ माइनस 12. 10 इज द पावर ऑफ माइनस 12. divided by 4 pi. What is your value of E naught? 8.85 10 raised to the power of minus 12. What is your radius R? 0.62 square. What does your electric field strength comes out to be? हाँ जी, electric field strength किसके equal आ जाएगी? 1.9 Newton Coulomb minus 1. Simple. The sphere in B is discharged by connecting earth of 0 volt through a resistor of this. अच्छा जी, अब आप एक resistor लगा रहे हो to discharge the sphere. Okay. Basically sphere को discharge करना, capacitor को discharge करना is one and the same thing. Calculate the time taken for the charge to fall to this value. बेटा डिस्चार्जिंग ऑफ कैपेसिटर में इक्वेशन लिखवाई थी कोई डिस्चार्ज की? डिस्चार्जिंग ऑफ कैपेसिटर में कोई डिस्चार्ज की इक्वेशन लिखवाई थी? Q इज इक्वल टू Q नॉट E माइनस टी ओवर टाउ. स्फेयर को डिस्चार्ज करना, कैपेसिटर को डिस्चार्ज करना, वन एंड द सेम थिंग. व्हाट इज योर फाइनल वैल्यू ऑफ चार्ज? 26 10 raised to the power of minus 12 coulombs because pico का prefix है. What was your initial value of charge? 83 into 10 raised to the power of minus 12 E minus T divided by the value of tau. What is tau equal to? Tau is your time constant. Time constant किसके equal होता है? Resistance, that is 120 mega ohm 10 raised to the power of 6 multiplied by the capacitance C. Capacitance की क्या value है बेटा? The value of capacitance, if we have it here, 69 picofarads. Okay. 69 10 raised to the power of minus 12. Can you calculate the answer? 69 10 raised to the power of minus 12. The answer of time constant comes out to be 8.28 10 raised to the power of minus 3 seconds. Place it here. 10 raised to the power of minus 3. Okay. Take this to the left side. Take this entire thing to the left side here. Okay. 10 raised to the power of minus 12 cancel out. 26 over 83 is equals to what? E minus T over 8.28 10 raised to the power of minus 3. Now take ln on both sides. Take ln on both sides. बेटा जब आप ln लोगे both sides पे what will happen? ln 26 over 83 ln E minus T over 8.28 10 raised to the power of minus 3. Cancel. इसको भी निकाल लेते हैं. ln 26 divided by 83. This comes out to be negative 1.161 minus T divided by 8.28 10 raised to the power of minus 3. Cancel. Can you calculate the value of time? Time की value निकाल लो बेटा. The time की value comes out to be 9.6 10 raised to the power of minus 3 seconds. Easy peasy, nothing complicated here. Let's further move ahead. अच्छा, अब क्या लिखा हुआ? I think after all an easy question. Usually questions of alternating current are easy, but let's see what we have in store here. An alternating voltage varies with time according to this formula. Okay, so this is the formula of your alternating voltage. V is in volts, T is in seconds. For the alternating voltage, show that the period is equal to this. Beta, do you remember the formula of alternating voltage? V is equal to V naught cosine WT. W की जगह क्या लिखा हुआ है? 40 pi. W is equal to 2 pi over capital T. 40 pi. Pi cancel out. Time comes out to be 0.05 seconds. Yeah, that's correct. Determine the root mean square voltage. You have to determine the voltage RMS. किस तरह calculate करेंगे? Can you realize the peak voltage is 18? V naught is equals to 18 volts. How will your RMS value come out to be? V RMS V naught divided by under root 2. 18 divided by under root 2. What will your answer come out to be? 18 divided by under root 2. आंसर क्या आ गया भाई? 12.7 volts. सिंपल इजी पीजी, कुछ भी हमने डिफिकल्ट नहीं किया यहाँ पे. चलो आगे बढ़ते हैं. On figure 7.1, sketch the variation of voltage with time t for the values of t from time t is equals to 0 to 100 milliseconds. अच्छा जी, voltage versus time का ग्राफ बनाना है. First of all, let's copy this exact thing downward. V is equals to 18 cosine 40 pi t. What is the maximum voltage, beta? Maximum voltage क्या है? 18. Where will 18 come out to be? If you are going from 0 to 20, 20 units cover कर रहे हो. How many boxes? 10 boxes. One box कितने units के equal होगा? 2 units. Where will 18 lie? Somewhere here. This is your starting point. Then it becomes 0. Then at 25 milliseconds क्या हो जाएगा? नेगेटिव. बेटा सिर्फ एक कोसाइन का कर्व ड्रॉ करना है, कीपिंग इन माइंड दैट योर टाइम पीरियड इज 50 मिलीसेकंड्स. एक कोसाइन का कर्व ड्रॉ कर दो शहजादों, कीपिंग इन माइंड दैट द टाइम पीरियड इज 50 मिलीसेकंड्स. और आपका एम्पलीट्यूड क्या है? 18. 18 से पहले आप गए 0 पे. देन फ्रॉम 0 यू वेंट टू -18. फ्रॉम -18 to 0. And from again to 0 to +18. Do the same thing for the next 50 milliseconds. +18 से 0, 0 से -18, -18 से फिर 0, 0 से फिर +18. Connect the dots again like this, like this. Simple, nothing complicated here. Let's see part C. The alternating voltage is rectified to produce an output voltage across a load resistor R as shown in figure 7.2. अच्छा जी, 7.2 में हम rectification कर रहे हैं to produce a output voltage across the load resistor. Okay, देखते हैं क्या लिखा हुआ है. Figure 7.3 shows the variation with time t of the power in the load resistor. बेटा, can you realize this power versus time graph में there are no flat lines? In this power versus time graph, there are no flat lines. That means this rectification is which type of rectification? बेटा ये rectification circuit कौन सा है? Full wave rectification. There are no flat lines in this power versus time graph. That means this circuit is full wave rectification वाला circuit. Let's see what the examiner is asking. State three conclusions that can be drawn from figure 7.3. The conclusions may be qualitative, that is theory based, and quantitative, that is number based. तो पहली conclusions तो मेरे पास आ गई. The rectification is full wave rectification because there are no flat lines in the power versus time graph. So you can write it here. Since there are no flat lines in power time graph, hence this is full wave rectification. बेटा सेंस आपके पावर वर्सेस टाइम ग्राफ में फ्लैट लाइंस नहीं है. दिस इज व्हाट? ये कौन सा रेक्टिफिकेशन है? फुल वेव रेक्टिफिकेशन. ठीक है. नाउ फर्दर मोर, और क्या कंक्लूजन्स हम ड्रॉ कर सकते हैं यहाँ पे बेटा? व्हाट फर्दर कंक्लूजन्स कैन वी ड्रॉ हियर? यस, क्या और फर्दर कंक्लूजन्स कैन वी ड्रॉ हियर? जस्ट फोकस ऑन द बोर्ड। और क्या कंक्लूजन ड्रॉ कर सकते हैं? इफ यू थोड़ा सा फोकस, थोड़ा सा अगर ध्यान दो, तो यू कैन कैलकुलेट द मैक्सिमम पावर हेयर एज वेल। आप यहाँ पे मैक्सिमम पावर भी निकाल सकते हो। दैट इज व्हाट the maximum power is, what, this value, that is 28. So let's write it down. The maximum power is 28 volts. And what will be your mean power? Mean power क्या हो जाएगी? Maximum power divided by 2. Maximum power divided by 2, that is 28 divided by 2, that is 14 volts. तो यहाँ पे आप लिख सकते हो that the maximum power is 28 volts and the mean power is 14 volts. भाई मैक्सिमम पावर आपकी 28 वोट्स है, मीन पावर आपकी 14 वोट्स है। परफेक्ट। फर्दर मोर व्हाट कैन यू डू हियर? और क्या कर सकते हो आप यहाँ पे? व्हाट एल्स कैन यू डू हियर? इफ यू थोड़ा सा रियलाइज ना, तो यू नो द मैक्सिमम पावर है ना, आपको मैक्सिमम पावर पता है। डू यू रिमेंबर some formulas for maximum power? Maximum power is equals to maximum voltage divided by R. मैक्सिमम पावर क्या है? 28। मैक्सिमम वोल्टेज क्या था? 18 का स्क्वायर डिवाइडेड बाय आर। कैन यू कैलकुलेट द रेजिस्टेंस? 18 स्क्वायर डिवाइडेड बाय 28 will give you the value of resistance. Can you calculate this resistance की value? Resistance comes out to be 11.57 ohms. That is 11.6 ohms. The resistance of the load resistor is 11.6 ohms. The resistance of the load resistor is 11.6 ohms. Simple. आगे बढ़ते हैं बेटा। Let's see what is written here. क्या लिखा हुआ है? Okay, so let's see this question. Figure 8.1 shows the three lowest frequency lines in the part of a emission spectrum for hydrogen that relates to electron transitions to the ground state, that is n is equals to 1. ठीक है भाई बेटा, if your electron is transitioning to the ground state, that is n is equals to 1, these are your three emission spectrum lines. Okay. The number represents frequency in 10 raised to the power of 15 hertz. अच्छा जी, ये numbers क्या represent कर रहे हैं? Frequency in 10 raised to the power of 15 hertz associated with the spectral lines. Perfect, perfect. Use the photon model of electromagnetic radiation to explain how the existence of spectral lines in the emission spectrum provide evidence for the discrete electron energy levels in the hydrogen atom. बेटा हमने बताना है हाउ द एग्जिस्टेंस ऑफ दीज स्पेक्ट्रल लाइंस। ये स्पेक्ट्रल लाइंस की एग्जिस्टेंस हमें किस तरह बता रही है दैट देयर आर डिस्क्रीट इलेक्ट्रॉन एनर्जी लेवल्स इन द हाइड्रोजन एटम। बेटा ये स्पेक्ट्रल लाइंस हमें किस तरह बता रही हैं कि देयर आर डिस्क्रीट इलेक्ट्रॉन एनर्जी लेवल्स इन द हाइड्रोजन एटम? व्हाट विल यू से? सो हाउ विल यू राइट योर आंसर? बेटा फर्स्ट ऑफ ऑल आपको ये बात याद रखनी है, इफ योर इलेक्ट्रॉन इज गोइंग फ्रॉम अ हायर एनर्जी लेवल, अगर आपका इलेक्ट्रॉन हायर एनर्जी लेवल से लोअर एनर्जी लेवल पे आ रहा है, इट विल ऑलवेज emit a photon. If your electron is moving from a higher energy level to a lower energy level, it will always emit a photon. You can write this out. पहला statement आप ये लिख सकते हो. You can say as the electron moves from higher energy level to lower energy level to ground state कर दो, from higher energy level to ground state, it emits a photon. जब भी इलेक्ट्रॉन हायर एनर्जी लेवल से लोअर एनर्जी लेवल पे जाता है, it emits a photon. Now the energy E, बेटा इस फोटोन की एनर्जी E किसके इक्वल होगी? The energy E of this photon will be equal to the higher energy level minus the lower energy level. अगर हायर एनर्जी लेवल की एनर्जी E2 है, लोअर एनर्जी लेवल की एनर्जी E1 है, the energy of the photon will be the difference between the electron energy levels. तो यहाँ पे लिख दो the energy, let's write it छोटा छोटा करके, the energy of photon is equal to the difference between electron is equal to the difference between electron energy levels. Electron energy levels. What will be your next point? You will say the energy of a photon, the energy of a photon depends on what? The energy of a photon depends on what? Depends on its frequency. बेटा एक फोटोन की एनर्जी किसके ऊपर डिपेंड कर रही है? इट्स फ्रीक्वेंसी पे. नाउ इफ यू रियलाइज देयर आर डिस्क्रीट फ्रीक्वेंसी ऑफ द फोटॉन्स. बेटा फ्रीक्वेंसी ऑफ द फोटॉन्स डिस्क्रीट है. लेट्स फॉर्म एन ऑर्डर. द फ्रीक्वेंसी ऑफ फोटॉन्स आर डिस्क्रीट. That means the energy of photons will be discrete. अगर energy of photons discrete होगी, that means the difference in electron energy levels will be discrete. और अगर difference in electron energy levels discrete होगा, तो electron energy levels भी discrete होंगे. Simple. This is how you will write the next statements. You will say थोड़ा सा ना अब मुझे लग रहा है छोटा छोटा करके लिखना पड़ेगा. यू विल फर्दर से यू विल फर्दर से since the frequencies are discrete, the difference in electron energy levels will be discrete, indicating what? बेटा अगर difference in electron energy level discrete है, this means what? There will be discrete electron energy levels, indicating since the difference in electron energy level will be discrete, indicating discrete electron energy levels. Let me summarize this entire question once again because there is a lot of theory here. बेटा आप क्या कहोगे? As the electron moves from a higher energy level to a lower energy level, it emits a photon. The energy of this photon is equal to the difference in energy levels. The energy of a photon depends on its frequency. Since the frequencies are discrete, they are countable. The number of electron energy levels are also countable. ठीक है? Now, let's further move ahead. आगे क्या सवाल है भाई? थोड़ा सा जूम इन करते हैं. अच्छा, द एनर्जी ऑफ द ग्राउंड स्टेट इज दिस. अच्छा जी, ग्राउंड स्टेट पे आपकी एनर्जी ये है. कैलकुलेट द एनर्जी इन जूल्स ऑफ द ग्राउंड स्टेट. अच्छा, इसको आपने जूल्स में कन्वर्ट करना है. Beta, always remember 1 electron volt is equals to 1.6 10 raised to the power of minus 19 joules. तो -13.6 कितने जूल्स के इक्वल हो जाएगा? 1.6 10 रेज़ टू द पावर ऑफ माइनस 19. दिस कम्स आउट टू व्हाट? हाँ जी, ये कितनी एनर्जी के इक्वल आ गया? 13.6 into 1.6 10 raised to the power of minus 19. This comes out to be negative 2.176 10 raised to the power of minus 18 joules. Let's convert it to three significant figures. Negative 2.18 10 raised to the power of minus 18 joules is your energy in the ground state. आगे बढ़ते हैं. Show that the energy difference between n is equals to 1, n is equals to 2 is this. बेटा हमने शो करना है कि दैट द लोएस्ट energy difference is equals to this. Whenever you are moving from n is equals to 2 to n is equals to 1, your energy difference is the lowest. हमने शो करना है कि lowest energy difference is equals to this. If you have the lowest energy difference, that means आप frequency भी क्या लोगे? Lowest. बेटा, do you remember the formula of energy of a photon? E is equals to hf. अगर आप energy lowest ले रहे हो, you are taking the lowest energy difference, you will take the lowest frequency as well. Lowest frequency क्या है? 2.47 10 raised to the power of 15. So the energy difference between n is equals to 2 and n is equals to 1 is equals to what? H क्या है? 6.63 10 raised to the power of minus 34. Frequency lowest क्या है? 2.47 10 raised to the power of what? 10 raised to the power of 15. Okay. What does your lowest energy difference comes out to be? बेटा lowest energy difference किसके equal आ रहा है? Let's calculate that. 6.63 10 raised to the power of minus 34 into 2.47 into 10 raised to the power of 15. This comes out to be 1.638 10 raised to the power of minus 18 joules. बेटा बट हमने आंसर जूल्स में नहीं निकालना. वी डोंट हैव टू कैलकुलेट द आंसर इन जूल्स. क्या करेंगे? वी हैव टू गिव द आंसर इन इलेक्ट्रॉन वोल्ट्स. व्हाट विल यू डू? 1 electron volt is equals to what? 1.6 10 raised to the power of minus 19 joules. 1.638 10 raised to the power of minus 18 joules. कितने इलेक्ट्रॉन वोल्ट्स के इक्वल होगा? x. X turns out to be what? 1.638 10 raised to the power of minus 18 divided by 1.6 10 raised to the power of minus 19. Can you calculate the answer? Hanji, this comes out to be what? 10.2 electron volts is your answer. Simple. Let's further move ahead. Complete table 8.1 to show the energy differences from the ground state and the energies of the level up to n is equals to 4 in the hydrogen atom. Use the space below for any working that you need. अच्छा जी, आपने space below use करनी है for any working that you need. ठीक है. The energy difference between n is equals to 1 and 2 is 10.2. बेटा energy level of E1 क्या है? Negative 13.6. What will be the energy level of n is equals to 2? यहाँ पे energy level कैसे निकालेंगे? The energy difference is equals to E2 minus E1. Energy difference क्या है भाई? 10.2. What is E2? We don't know. Negative. What is E1? Negative 13.6. Take it to the other side. 10.2 minus 13.6 is equals to your E2. E2 की वैल्यू निकाल लो भाई, क्या आ रही है? What is the second energy level? Second energy level is negative 3.4. ये आ गया आपका negative 3.4. Now you have to calculate the energy difference when you travel from n is equals to 3 to n is equals to 1. बेटा आप जब आप n is equals to 3 से 1 पे जा रहे हो, then you have to calculate the energy difference. How will you do that? Energy difference is equals to HF. Which value of frequency will you take? The middle value, 2.92. H की वैल्यू क्या है? 6.63, 10 raised to the power of minus 34. Frequency की value is 2.92. 2.92, 10 raised to the power of 15. Can you calculate the energy difference? Oh, this is a very lengthy paper. 34 into 2.92, 10 raised to the power of 15. This comes out to be what? 1.94, 10 raised to the power of minus 18 joules. Ab again convert it into electron volts. To convert this into electron volt, convert into electron volts. If you have to convert it into electron volts, what will you do? 1.94, 10 raised to the power of minus 18 divided by 1.6, 10 raised to the power of minus 19. Can you calculate the electron volts? 1.6, 10 raised to the power of minus 19. Electron volts comes out to be 12.09. If you convert it to three significant figures, 12.1 electron volts is your answer. तो बेटा n is equals to 3 से 1 जब आप जा रहे हो the difference in electron volts is 12.1. एनर्जी निकाल सकते हो, n is equals to 3 निकाल सकते हो. Yes. Now let's do this working here only. यहाँ पे ही कर देते हैं working. The energy difference between 3 to 1, E3 minus E1 करके calculate करोगे. The energy difference is 12.1. What is E3? We don't know. What is E1? E1 was negative 13.6. ठीक है. What does your E3 comes out to be? 12.1 minus 13.6. बताओ ये क्या आंसर आ गया? This comes out to be negative 1.5. Simple. Now you have to calculate the energy difference when you are going from n is equals to 4 to 1. Maximum difference in energy, तो आप maximum frequency लोगे 3.09. Let's do it here. When you are going from n is equals to 4 to 1, frequency क्या हो गई? 3.09, 10 raised to the power of 15. Can you calculate the energy difference? HF. H क्या है? 6.63, 10 raised to the power of minus 34. Frequency is 3.09, 10 raised to the power of 15. Can you calculate the 6.63, 10 raised to the power of minus 34, 3.09, 10 raised to the power of 15? This comes out to be what? 2.05, 10 raised to the power of minus 18 joules. Now convert it into electron volts. 2.05, 10 raised to the power of minus 18 divided by 1.6, 10 raised to the power of minus 19. बताओ इसका आंसर इलेक्ट्रॉन वोल्ट्स में क्या होगा? This comes out to be 12.8 electron volts. Put it here. आपका एनर्जी डिफरेंस क्या आ गया बेटा? 12.8. Now lastly calculate this n is equals to 4 as well. When you are going from n is equals to 4 to 1, the energy difference is equals to what? E4 minus E1. Energy difference क्या है? 12.8. E4 minus E1 की वैल्यू क्या थी? Negative 13.6. What does your E4 comes out to be? 12.8 minus 13.6. Your answer comes out to be what? बेटा आंसर क्या आ जाएगा? Negative 0.8 electron volts. रख दो यहाँ पे negative 0.8. I am really tired doing this paper. Very, very tired. Chalo, let's see this. State what is meant by mass defect of a nucleus. Mass defect of a nucleus का मतलब क्या होता है? Difference between the mass of a nucleus and the sum of individual nucleons separated till infinity. लिख लो बेटा. मास डिफेक्ट का मीनिंग क्या होता है? डिफरेंस बिटवीन द mass of the nucleus, difference between the mass of the nucleus and the sum of individual nucleons separated till infinity. बेटा मास डिफेक्ट क्या होता है? द डिफरेंस बिटवीन द मास ऑफ अ न्यूक्लियस and the sum of individual nucleons separated till infinity. Let's further let's further move ahead. Okay. Uh, ठीक है सही है. The nuclear fusion reaction for the formation of helium from deuterium is represented by deuterium से helium किस तरह फॉर्म होता है रिप्रेजेंट किया हुआ है. Figure table 9.1 shows the masses of the nuclides involved in the reaction. Okay. Calculate the energy released in the formation of 1 mole of helium. कैसे निकालोगे energy released? First of all, you have to calculate the mass defect. How will you calculate the mass defect? Mass of the reactants minus the mass of the products. अच्छा जी, reactants का mass क्या है बेटा? 2 times 2.013553 U. What is the mass of the products? 4.001505. Can you calculate the mass defect, beta? 2 into 2.013553 minus 4.001505. The mass defect comes out to be what? 0.025601 U. Mass defect आ गया आपका. Can you calculate the energy released? Yes. Mass defect into c square. Mass defect क्या है भाई? 0.025601. What is the value of U? 1.66 10 raised to the power of minus 27. What is the speed of light? 3 into 10 raised to the power of 8 ka whole square. Can you calculate the energy released? Energy released निकाल सकते हो बेटा? Yes or no? This comes out to be what? The energy release comes out to be 3.82 10 raised to the power of minus 12 joules. ये आपकी एनर्जी रिलीज्ड आ गई. बट प्लीज 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 रियलाइज वन थिंग. दिस इज द एनर्जी रिलीज्ड फॉर वन मॉलिक्यूल. बेटा ये एनर्जी रिलीज्ड है फॉर वन मॉलिक्यूल. यू हैव टू कैलकुलेट द एनर्जी रिलीज फॉर वन मोल. कैसे कैलकुलेट करें सर? वी डोंट नो हाउ टू डू इट. बेटा एक मोल में कितने नंबर ऑफ मॉलिक्यूल्स होते हैं? हाँ जी बच्चों, एक मोल में कितने नंबर ऑफ मॉलिक्यूल्स होते हैं? डू यू रिमेम्बर? वन मोल हैज 6.02 10 raised to the power of 23 मॉलिक्यूल्स. तो बेटा एक मोल की एनर्जी निकालने के लिए क्या करेंगे? मल्टीप्लाई दिस एनर्जी 3.82 10 raised to the power of minus 12 by what? 6.02 10 raised to the power of 23. Can you calculate this answer, Shazado? This answer comes out to be 2.3 10 raised to the power of 12 joules as your energy. सिंपल एज दैट. कुछ भी हमने कॉम्प्लिकेट नहीं किया, ज़र्रा बराबर भी इसको कॉम्प्लिकेट नहीं किया. चलो लेट्स फर्दर मूव अहेड. अच्छा, द स्टार with a weird name, Cyrus, has a radius of this, okay, and loses mass due to nuclear fusion at a rate of this, okay. Assume that the power of the radiation emitted by the star is equal to the power released by this process, okay. जो भी आपकी power produce हो रही है by the star, that is equal to the power released by this process, okay. Determine a value for the luminosity of Cyrus. बेटा luminosity of Cyrus की वैल्यू कैसे निकालोगे? luminosity बेसिकली क्या होती है? पावर. ओके सर, पावर कैसे निकाल सकते हैं? एनर्जी डिवाइडेड बाय टाइम. कैन यू कैलकुलेट द एनर्जी चेंज इन मास? c square divided by time. Now if you realize you are given a very weird quantity. आपको गिवन है कि एक सेकंड में कितना चेंज इन मास हो रहा है. यू आर गिवन चेंज इन मास ओवर टाइम. आपको चेंज इन मास ओवर टी की क्वांटिटी ऑलरेडी गिवन है, दैट इज व्हाट? 1.09. 10 raised to the power of 11 multiplied by c square, that is the speed of light का square. Can you calculate the luminosity? Luminosity निकाल सकते हो बेटा. Luminosity आ गई 9.8 when 10 raised to the power of 27. 9.8 when 10 raised to the power of 27. And since luminosity is the power of the star, यूनिट्स क्या आ जाएंगे? वोट्स के यूनिट्स आ जाएंगे. सिंपल. आगे बढ़ते हैं. यूज योर आंसर इन सी पार्ट 1 टू डिटरमाइन द सरफेस टेम्परेचर. सरफेस टेम्परेचर निकालना. लुमिनोसिटी इज इक्वल टू व्हाट? हाँ जी, 4 पाई स्टेफन बोल्ट्जमैन कांस्टेंट आर स्क्वायर टेम्परेचर की पावर 4. Luminosity की value is 9.81 10 raised to the power of 27 divided by 4 pi. What is the Stefan Boltzmann constant? Stefan Boltzmann constant की value क्या है? 5.67 10 raised to the power of -8. What is the value of surface temperature? हमें नहीं पता. Do you know the value of the radius? Radius की value आपको पता है? 1.19 10 raised to the power of 9. 1.19 10 raised to the power of 9 का होल स्क्वायर इज इक्वल टू टेम्परेचर की पावर 4. ये किसके इक्वल हो जाएगा? टेम्परेचर की पावर 4 के इक्वल हो जाएगा. इफ यू टेक दिस आंसर आउट, अगर इसको हम आंसर निकाल लें, 9.81 10 raised to the power of 27 divided by 4 pi 5.67 10 raised to the power of -8 into 1.19 10 raised to the power of 9 का whole square. This comes out to be what? 9.72 10 raised to the power of 15 is equals to temperature की power 4. Take square, नहीं, take 4 का रूट like this. आप कैलकुलेटर में इस तरह 4 का रूट ले लो. 9.72 10 raised to the power of 15 gives you your surface temperature. That is 9930 Kelvins as your answer. 9930 Kelvin is your surface temperature. आगे बढ़ते हैं. Explain how cosmologists use standard candles to estimate the distance of a galaxy from the Earth. You will say standard candles have a known luminosity. Standard candles के पास क्या होती है? They have a known luminosity. Have a known luminosity. I always mess up this spelling. I hope I don't do it this time. Standard candles have a known luminosity. The radiant flux intensity F is measured. The radiant flux intensity F is measured on Earth. Lastly, क्या बताओगे? Apply the formula F is equals to L over 4 pi d square to calculate the distance d between, to calculate the distance d between what? Between the galaxy and Earth. Simple. Let's further move ahead. State what is meant by contrast in an X-ray image. अच्छा जी, what is the meaning of contrast in an X-ray image? Difference in degrees of blackening. You can write it here. Difference in degrees of blackening. Simple. Let's further move ahead. X-rays of intensity I naught are incident normally on a structure as shown in figure 10.1. अच्छा जी, यहाँ पे आपकी एक्सरेज हैं I naught that are incident on this structure. Okay. Material P has a linear attenuation constant of this. अच्छा, material P कौन सा है? ये वाला. This white वाला material has a linear attenuation constant of this. X-rays emerging from the structure in region A has an intensity of this. चलिए यहाँ पे जो ए रीजन पे इंटेंसिटी इमिटेड आ रही है, दैट इज, लेट्स से, the X-rays that are coming out from here have an intensity of 0.053 I naught. Okay. Show that the intensity of the X-rays emerging in region B is 0.13 I naught. बेटा region B में जो आपकी rays बाहर आ रही हैं that have an intensity of 0.13 I naught, ये आपने show करना है. So do you remember the formula? I is equals to I naught E minus linear attenuation constant multiplied by the length. Intensity that hits the surface, तो I नॉट है, E माइनस लीनियर एटेन्यूएशन कांस्टेंट क्या है, 0.35, डिस्टेंस क्या है 5.8. बताओ क्या आंसर आ जाएगा. हाँ जी, माइनस 0.35, 5.8, दिस कम्स आउट टू बी व्हाट, 0.13 I नॉट. बेटा द इंटेंसिटी दैट कम्स आउट टू बी इन रीजन बी इज व्हाट, 0.13 I नॉट. सिंपल. आगे बढ़ते हैं. Show that, या determine the linear attenuation constant of material Q. आपने linear attenuation constant of Q बताना है. How will you do that? बेटा अगर आप रियलाइज करो, रीजन ए में व्हाट इज हैपनिंग, रीजन ए में यू हैव मटेरियल Q ऑफ 2.1 सेंटीमीटर एंड ये जो रिमेनिंग मटेरियल है, दिस रिमेनिंग मटेरियल दैट इज 2.1 माइनस 5.8. अच्छा, ये रिमेनिंग मटेरियल दैट इज 1.85 सेंटीमीटर, 1.85 सेंटीमीटर. सर हाउ डिड यू कैलकुलेटेड इट? बहुत सिंपल है. द टोटल लेंथ इज 5.8 माइनस 2.1 डिवाइडेड बाई 2, 1.85 सेंटीमीटर. दोनों साइड पे 1.85, 1.85 इज ड्यू टू मटेरियल पी. तो बेटा इफ यू अज्यूम कि यहाँ पे एक एक्स रे आके हिट करती है ऑफ इंटेंसिटी आई नॉट, it has to pass through material P, 1.85, 1.85. It also has to pass through material Q. So if I do the working here, अगर यहाँ पे मैं थोड़ी सी working कर दूँ, the intensity that we get in region A is equals to I naught E minus mu 0.35. That is the linear attenuation constant of material P. और मटेरियल पी में आप कितना डिस्टेंस ट्रैवल कर रहे हो, 3.7. ओके, मल्टीप्लाइड बाय ई माइनस द लीनियर एटेन्युएशन कांस्टेंट ऑफ मटेरियल क्यू मल्टीप्लाइड बाय 2.1. बेटा बात समझ आई है मैंने क्या किया? फर्स्ट आई हैव टेकन द लीनियर एटेन्युएशन कांस्टेंट ऑफ रीजन पी multiplied by the distance traveled in region P. Then I have taken the linear attenuation constant of region Q multiplied by the distance traveled in region Q. I की जगह क्या पे क्या आ जाएगा? द इंटेंसिटी ट्रांसमिटेड की जगह पे क्या आ जाएगा? 0.053 आई नॉट इज इक्वल टू आई नॉट. ई और ई मल्टीप्लाई हो रहे हैं, पावर्स विल गेट एडेड अप. 0.35 into 3.7, this comes out to be minus 1.295 minus 2.1 mu q. ठीक है. Now I naught cancel out. 0.053 is equals to E minus 1.295 minus 2.1 linear attenuation constant of Q. अब क्या कहोगे? टेक एल एन ऑन बोथ साइड्स. बेटा एल एन लेनी है आपने बोथ साइड्स पे. एल एन 0.053 एल एन ई minus 1.295 minus 2.1 mu q. Cancel, cancel. L. Now I think we can solve it on the downside as well. अब इसको हम नीचे भी सॉल्व कर सकते हैं मेरा ख्याल है. हाँ, इसको चलो नीचे रख के सॉल्व कर देते हैं. हम्म. ठीक है, लेट्स erase this. ठीक है. Now ln 0.053 किसके इक्वल हो जाएगा? ln 0.053 किसके इक्वल हो जाएगा? -2.937 इज इक्वल टू व्हाट? -1.295 -2.1 म्यू म्यू क्यू. ठीक है, ये लीनियर एटेन्यूएशन कांस्टेंट है ऑफ क्यू. लेट्स टेक दिस टू द लेफ्ट साइड. Ah, this is a very calculation heavy paper. I'm really tired. Plus 1.295 divided by -2.1 is equals to the linear attenuation constant of Q. Answer plus 1.295 divided by -2.1. The linear attenuation constant for region Q comes out to be what? 0.782. Correct to three significant figures. आगे बढ़ते हैं. Use your information in B part 1 to suggest why the X-rays emerging from the structure form an image that has poor contrast. बेटा जो X-rays emerge हो रही हैं, why do they have a poor contrast? Because अगर आप realize करो, the X-rays emerging out from A have an intensity of what? 0.053. X-rays emerging from B have an intensity of 0.13. Beta, you don't have a large difference between the intensities. You don't have a large difference between the intensities. अगर आप फर्स्ट वाली इंटेंसिटी को मल्टीप्लाई करते हो या इंटेंसिटी ऑफ रीजन ए को मल्टीप्लाई करते हो बाय अ फैक्टर ऑफ 2.5, you will get the intensity of region B. There is not a large difference between the two intensities, hence you have a poor contrast. ये लिख दो. You can say there is not a large difference between the intensities of region A and B, hence not a good contrast. There is not a large difference between intensities of a region A and B, hence not a good contrast. Simple. आगे बढ़ते हैं. Let's further move ahead. Explain how X-rays are used in CT scanning to produce three-dimension image of an internal structure. बेटा एक्स रेज किस तरह यूज होती हैं इन सी टी स्कैन्स टू प्रोड्यूस अ 3D इमेज? व्हाट विल यू से? एक्स रेज आर यूज टू जनरेट images या scan of thin sections from different angles. बेटा फर्स्ट चीज आप क्या लिखोगे? एक्स रेज आर used to generate scans from different angles and the object is viewed and the object is viewed by what? And the object is scanned या viewed is viewed in thin sections. What will be your last point here? Scanning is repeated for all sections and the data is compiled to form a 3D image. Scanning is repeated for all sections and data is compiled to form a 3D image. Simple as that, nothing complicated here, easy peasy. At last, this paper is finished. This really took my life away. So, yeah, I hope this was clear to all of you. If you have any questions, you can ask in the chat.